Good morning. Do you hear me? So YouTube tells me there are 5 concurrent viewers, so I guess I'm not completely alone talking into the void, which is nice. Let's maybe quickly see if actually my toot cat's here. So okay, let's maybe start with some housekeeping. Oh, concurrent viewers dropped down to 1. Hans says yes even. All right, hello Hans, long time no see. Okay, so maybe a little bit of housekeeping. The official hashtag for this series is going to be ActivityPub in Clojure, and so if you want to engage on the Fediverse, then please use that hashtag. Then we can all sort of follow the conversation there. Also, yes, feel free to talk to me in the chat. I will try to keep an eye on that and address anything that comes up. As you see, chat is also included in the actual video. Okay, I've been a little bit sick this week, and feel like I could have used a little bit more preparation, but I guess that's always the case. So this might be a little bit rambling, but let's see where we can get. So, okay, I've started a little bit of explorations, and I'm calling this project Souk, which is Arabic for sort of like a bazaar, if you will, collection of small shops. I kind of imagine like the hubbub there. So let me maybe grab this here and start my REPL. I'm using Launchpad, of course. Nope. Yeah, I already have a couple things here because I've already been exploring a little bit. I wanted to try to keep the stream a little bit on topic, so some of the initial explorations I've been doing behind the scenes, in particular in a couple of these REPL sessions. But my source directory does not exist yet. So we're basically going to be looking at some of the stuff, and as we go, sort of build up the stuff in source. Okay, so what have I done so far? I've experimented a little bit with JSON-LD. I've looked at how I want to use Postgres. That's going to be our backend database. Poked a little bit at using RSA public key cryptography to sign things, which is something we're going to need. And I've also set up FRP, which is, I don't know if you're familiar with ngrok. It's a similar thing. It's basically something that allows me to have a computer in the cloud. In this case, I spun up a small machine on GCP that's, on the public internet. There's a domain name pointing at that. The domain name is dev.squid.casa. The thing is, like, a lot of these things we're gonna need fully qualified URLs to identify things, and so I figured, having an actual domain name that's accessible from the outside, and that we're going to use throughout development is going to be helpful for testing as well. Like, we can see if other ActivityPub instances can reach us and so forth. And so any HTTP requests to this one are going to go to port 3838 locally, and so that's where we're going to run our HTTP endpoint. But we're not that far yet, so let's start with the basics. Let's see, JSON-LD stuff. Okay. Yeah, and so as I go along, let me actually start cleaning this stuff up into proper namespaces. So even though I already have a bunch of code here, I'm gonna basically move it over to proper source files and clean it up and show it as we go along. Now, what am I gonna prefix this something, or I'm just gonna call this suk? Let's call this, let's keep it under lambda island suk JSON-LD .clj. Okay, so we have a brand new JSON-LD namespace. We're gonna need Hato in there for, so Hato is a wrapper around the HTTP client that comes with Java. I think it's Java 9 and later that bundles this. So this allows to make HTTP requests. Yeah, I was using Cheshire here, Cheshire for HTTP for JSON parsing because Hato uses that under the hood, so it pulls it in automatically. But actually, I want to use chart, which is sort of the latest and greatest JSON parsing in Clojure. Okay, so that should have added here to our deps Eden. Since I'm using Launchpad, this has now hot reloaded my deps Eden. So let's see, what are the namespaces of chart? Chart, zero dependency, JSON parsing, chart.api. Chart.api, as we'll just call this JSON as well. Right. Okay, and now, okay, I need a little helper just to like fetch stuff where it sets all the right headers to so that the server knows to respond with JSON. Although I'm not 100% sure if this how we'll do it in proper code. Like this is how I did it in the REPL session. Let's at least call this JSON get, so that we can maybe also have a JSON post and a JSON put later. You know, just a couple things. Set the accept header. There is actually a specific MIME type for JSON-LD, but I found that Mastodon doesn't recognize that, so we just tell Mastodon, okay, give us JSON. If we don't do that, then some of these endpoints will return HTML. And we're not gonna keywordify the keys yet. When it's coming from raw JSON, I like to keep things as string to sort of so that I see that like this is the raw stuff that we got back. And then we're gonna munch that into something much nicer, Clojure-ish. But we'll get to that. So, okay, let's actually start looking at some real stuff, right? So this is the URL for that uniquely identifies myself, my profile, on the toot.cat server, which is my main account. So if we fetch that, yeah, we get this big thing back. We're just gonna get the body. Yeah, and so okay, there, you know, here's a URL for our followers, and we could fetch that. There's a URL for the inbox where we can eventually send messages. This is the public profile URL that's sort of accessible in the browser. This @context and anything here that starts with an @ is JSON-LD stuff, and we're going to talk about that. But yeah, this is basically all the stuff you would expect. There's my profile image. There's the public key for this account. So when different instances talk to each other, they sign the requests to know that a specific user initiated a specific message. So that'll be interesting. And then there's an outbox here. We've also seen an inbox. This is basically how you're gonna send messages back and forth. And actually, I haven't tried this yet, but I kind of wonder if like by just fetching the outbox, if we can actually see my recent posts. I think we should. Yeah, so this is an ordered collection, which means that it's a paginated thing and you kind of need to follow these links. Let's try that. And now we have here ordered items. And indeed, let's see, where's the actual content here? Yeah, content. Ooh, and that's all rendered as HTML. That's interesting. Didn't realize it did that like that. But I suppose it makes sense. Ooh, there's even an atom URI. There's a bunch of good stuff here. Okay, now what I wanted to talk about. Do we have some folks? So YouTube tells me there are 4 concurrent viewers. Please do weigh in on the chat. Is always nice to feel like it's a little bit interactive and not just me talking into the void. Okay, so there's this context thing here, okay? And in this case, this context contains, it's a well, in JSON terms it would be an array, but it's some sequential thing, and we find a couple different things here: a URL, a map. So this add context can be just a URL. It can be a map, or in JSON terms an object, or it can be a list of, you know, all of the above and basically recursively all of that. And if it's a URL, then you basically expand that recursively as well. So let's see. So this is a URL we'll see multiple times. This is defines the main activity streams vocabulary. So there's an add context in here with a whole bunch of things. What you see here is basically a mapping from some short term, like let's say inbox, to a URL. It's gonna look something like this. Now, actually, a lot of these that you see here look like this. They're not full URLs. They're like some prefix, colon, some suffix. But then we can find that prefix in this map, or in a previous context map if we're sort of recursively following the process. And so if it says inbox as inbox and there's as this full URL, then that actually means that that fully expanded inbox is this. And so what this context really does is map these short terms to complete URLs. Yes, those are their URIs are actually IRIs. Yes, I use them interchangeably, but you're correct. They're not necessarily dereferenceable, so they're just names. I heard something. Is someone mentioning me here? Yes. So a URL is a universal. I think it's a uniform resource locator, which means that it points somewhere, typically on the network, at a thing, and you can get that thing via the protocol that is specified. Whereas a URI is a uniform resource identifier, which is sort of a superset like URLs are URIs, but not always vice versa. And then there's a bigger superset of that, which are internationalized resource identifiers, or IRIs, which are URIs, but with some additional syntax for including character sets beyond ASCII and stuff like that. Yeah, I use these terms loosely, and I know I probably should be a bit more particular about it, but yes. So, and yes, also good point, Hans. And I wanted to. I'm getting to that. I'm building up to that. So, JSON-LD. So we're talking about JSON-LD. JSON-LD is a standard from the WLC. It's JSON linked data. And JSON-LD has a particular relationship to RDF, the resource description framework. So this is another standard, I believe also from the W3C. RDF stems from the attempts at building the semantic web. So the idea was, no, I really appreciate it, Hans. Do please keep the comments coming. It's good to have some interactivity, and do call me out if I if I'm not being correct. I I'm also just winging it. But yeah, so the semantic web is this idea that we have the web, which contains a lot of information, mostly as HTML pages, and these pages are made to be rendered in a browser and read by humans, but they're not really meant to be parsable by machines in terms of actually getting information out of that and, for instance, sticking it in a database and further processing it. Whereas the web could be that. The web could be this huge distributed database of information that you could query and ask questions, and we're sort of like Google and others through analyzing the text and so forth, sort of have managed to get information out of it, but it's not in the first place meant as machine readable. RDF and the semantic web is the idea that actually it could be that, and that there's multiple representation formats that could carry the same data model for describing things about things. And the way that RDF works is going to be very familiar to anyone who's used a data log database or a triple store. So in Datomic, we have these triples, entity, attribute, value. I think RDF uses different terms. It's like object predicate something, but it basically comes down to the same thing. You could say Clojure, type of language, functional, right? So you have a thing that you're making a statement about. You have the statement, the property, the attribute that you're describing, and then that corresponds with some value. And so basically just like having yes, subject, predicate, object is what RDF calls it. Now when and so this is where we get back to what we were talking about here. Why does it matter that we have these complete URLs? It's because when you have something like functional or even Clojure, a simple string like that, what does functional mean? In this case, I want to say that this is a functional programming language, but maybe someone else uses the word functional to mean something else, because it does have multiple meanings. So the idea is there that these identifiers, fully qualified identifiers, come into play, where someone, in this case the W3C who owns this domain, can coin this fully qualified identifier and attach some meaning to it. Say, okay, well, an activity streams inbox using this fully qualified identifier, which we control because we control the domain, we now coin that the meaning of this is this, right? And so now basically these triplets become triplets of URLs, HTTP or HTTPS. And so that's, you know, in a nutshell, the data model of RDF, of a lot of graph databases. And so JSON-LD is compatible with RDF. It's not, it's kind of interesting. It, you know, like the bits I've read about it, it's not directly meant as a serialization format of RDF, but you can turn it into RDF and vice versa. And it sort of tries to bridge the gap in like having things that look very much like plain JSON APIs, the way that people like expect them to look. And so that's why when we look at this again, here my profile, right? So I have here a name field, name Arne Brasseur. And there's no full URL here. It just says name, and you can parse it as such. You can ignore that content, that context key, and just say, okay, well, you know, there's a name property. I'm going to look for the name property. But you can use that context to fully expand these things to basically something that looks a lot like RDF, using these fully qualified identifiers. Now, the first step to that is actually expanding this context. So if we look at this context again, okay, well, this one, yeah, okay, this is for Outbox. Users Plexus has a context which sort of contains the activity streams vocabulary, some W3C security vocabulary, and then a bunch of extra things defined by Mastodon. And so our first step in actually sort of turning this into a canonical representation with full URLs is going to be expanding this this context. And so I have some logic for that here. Yeah, I'm already memoizing it, but actually I'm not going to do that. I decided that instead of doing that, let's keep this plain for now. This has become JSON get. Okay, so basically, let's quickly walk through this. Expand context is a recursive process. Basically, we're gonna see in this case that we get something sequential back, and so we're gonna call expand context, which each thing in the sequence. Now this is a reduce because later things in the sequence might use definitions from things that came earlier in the sequence. And so we start with an empty map. We're gonna add everything from this one, activity streams, then we're gonna add everything from security, and then we're gonna add these things. Yeah, let's get that debugging stuff out there for now. And so finally, it bottoms out in things that are maps, like the one you see here. And then, yeah, we're going to add that to our current context with an int2 with a transducer in the middle that does some stuff that basically tries to find these shortened URLs, expands them to full URLs based on stuff that's already in the context. Now, this context also can contain type information. And so actually what we eventually want to get to is a map going from short name to something that has an ID key, which is going to be the full URL and possibly a type name and possibly some extra stuff. JSON-LD does have some extra values that can be in there that we're not going to care too much about yet. I don't have the string namespace yet. Okay, so let's see. So we got the context here. That's what you see on the right. Now let's see if we expand that. And now we get this. So this is cool, right? So now we can say that, okay, let's see. We had this name property earlier. Okay, well, name means that it's an activity stream's name. In this case, there's no type information, but href is an activity stream's href and its type ID, which basically means that it's another fully qualified identifier that you could use as an entity that has its own properties and so forth. So this is how you get links in the data model. This is also something, maybe something to point out in JSON-LD. Where does the link data come in? If I have, let's say, a profile property, this could be a fully qualified link to, some profile. And you can fetch that and get basically a map back, but it can also embed the map. Like, those are basically equivalent. So this is where the link data comes in, that basically there are like hyperlinks in there. You can either just embed the information or link to the information. Okay, so we now have a fully expanded context. Now what I actually want to do here is introduce a bit of state. Basically, I wanna keep an atom with mappings from URL to the context, so that we don't fetch the same context URL twice. And by doing it this way, it also means that we're going to be able to seed this with all the common ones that we're using, so that you don't have to like be fetching these contexts every single time that the app restarts. So let's do that. Oh, this is a regular def. Let's make a fetch context, which takes a URL, which is really just going to be this, except that we're gonna do this. Actually, let's maybe do an if let then we return it, and if not, then we swap our context cache. And there's some chance of a razor condition here, I suppose, but I mean, worst case scenario, we do the same request twice. That's not the end of the world. So swap context cache. Yeah, we'll just do this. So this is our cache. Assoc URL with this thing. And then that will return the new map. I don't know if this is the best way to write this, but I think this should do the trick. If you're cringing right now at my non-thread safe logic here, then do call me out. Okay, so now we replace this with fetch context, and call expand context again. Assoc cache. What went wrong here? Oh, because we're okay. Body with body context. No, we already have all that. Just this. Yeah. Also, yeah, we're not dealing with request errors very well right now. That's fine. This is also, yeah, I do want to point out, like, this project that I'm making, this is not meant to be like a super, like production ready definitive implementation for Clojure. Like the main goal of this project is to make some interesting streams and talk about these things. And I do hope we get to something that actually works. But I am gonna take some shortcuts. Okay, let's see. Yeah, so we can. So basically, the idea is that like we can now bootstrap our app like this, and prevent some fetches. Okay, so that's the context. Now, what are we gonna do with this context? Let's clean up a little bit here. Actually, let's move this. Okay, gonna move this somewhere else for now. And I'll use a refer all so I don't have to like change all the stuff that we've been poking at here. Okay, so this is starting to turn into some real code. So we are able to expand the context now. Now what we want to do is use that context to further canonicalize the result. And so this is going to be apply context, and there's some hairy details already, a little bit of, I'll just gonna copy this to our JSON-LD namespace and then talk a little bit about it. Okay, so we have expand ID, which is going to take an ID, either a plain one like here leaf, or this shortened URL like as:\leaf, and the current context, and expand it to ideally a fully qualified URL if it can. If not, it just returns the thing. So that's expand ID. Apply context now takes some value and a fully expanded context and sort of walks the whole thing, because it needs to be, objects can be nested, so it needs to do it recursively. Also, types can use these shortened names. So let's maybe look again at here, users plexus. So this should have a at type key. No, it doesn't want to have a. Okay, this one doesn't. Where have we seen type? Oh, actually, it has a. Yeah, it has a type person here. Okay. And in our expanded context, type is actually shorthand for @type, with @type being a special keyword in JSON-LD which denotes the type of the thing. And then person is AS person, activity streams person, activity streams. We've seen that. Do I still have it here? Yeah, means that it gets this prefix. So basically, this type person means that this is @type activity streams person. And so that's also how we want it to look in our fully expanded entity. And so that's why you see here apply context, that we check for @type, have some special handling there, and so forth. For the rest, it's like basically recursively walking over the map that you're given. Take that out. And also, if there is additional information in the context, then we want to have that in this result as well. And then finally, we have an expand, which is gonna get the context, expand that context, and then use the context to expand the thing. Okay, so now what we can do is grab our profile once more and expand it. All right. So now, here, let's look at this. Like, for instance, if you look at the keys of this thing. So we have @ID and @type, which are JSON-LD specific keywords. @ID, again, I don't know, like not everyone might be familiar with Datomic, but the thing is, like we talked about these triplets before, entity, attribute, value, and say you have a bunch of these, so you can represent it like this, basically as a list of triplets, or you can make it into a map, you know, attribute 1, value 1, attribute 2, value 2, and then you need some special key to say, well, you know, this is the entity that this is all about. And so these are basically, like in Datomic, you also have this duality where sometimes you look at things as maps, and sometimes you look at things as what Datomic calls datums. And so same here, we have this @ID and then a bunch of key value pairs, and then the values are the corresponding values. Now here, in this fully expanded version, these will either have an @value if they're basically like some atomic, you know, final value, a string, a number, or they will be a map with an @ID, and that means that it's basically a link to something else. Yeah, and so here you see, for instance, my encryption key. It has an ID where we can fetch that key, or at least, I guess I'm not. Can we fetch the key there? The fact that that's a fragment URL makes me think that we can't, and that this is really just an identifier. So in this case, it does have the actual values in there, but it also has an ID because it has a unique identifier that identifies this entity, or this object. I don't know what the right terminology is in JSON-LD. Now this is, I will admit, like, so I basically sort of hacked together my own JSON-LD expansion algorithm, which is not spec compliant. And there's like the fact that it here has like ID value, that's probably a little bit of weirdness of how I'm doing things. I don't think that's exactly how it's supposed to be. We might tweak that later. Now another thing is, let's see, is this where I had first experiments where I was using yeah, like this titanium JSON-LD library from Java. And if you look at how this one expands, so okay, we get a JSON doc and we can expand it. Is this, yeah, so this is some Java thing. I think this one makes it print a little bit nicer. Yeah. Now one thing. Oh, am I already? Yeah, I'm already doing first here. Let's not do that. Actually, yeah, let's do, this is a bit more of a straightforward mapping. So I'm basically just taking, you know, their values that they, you know, their recursive data structure, and turning it into values that are a bit more familiar in Clojure. Now, one thing you'll notice here is that everything is a vector, right? Like there's no like, you know, name. We know that you know, in the data model, presumably you have a single name and a single profile name, but everything is a vector. Hello, we get something new on the chat. Welcome. what's up with that? Well, this goes back to, you know, RDF and you know, this triplet triplet way of representing things. So, okay, say I have, you know, Plexus name is Arne Brasser. And so you can represent that in a map saying, okay, well, Plexus, ID Plexus has a name of Arne Brasser, right? But there's nothing in this triplet data model from preventing you of saying, well, you know, Plexus name is Van Paul. Those are my middle names. And actually, it might be interesting here to pull up. Asami has some nice visualizations of these things. Where's the link? Introduction page. Right, so really what we're representing here are graphs. You know, Plexus, first name, Arne Brasser. So there's a node, an edge pointing at another node. And you can have another edge from the same node pointing at a different node, but you know, with the same predicate, the same attribute on the edge. Datomic solves this by having you predefine which attributes have a cardinality of 1 and which have a cardinality of many. Asami does not do this and actually has more of the graph database semantics where it basically can always be either. And so yeah, when you get something like this to represent this in a map, you would turn this into a vector. And so since the Java JSON-LD expansion algorithm that we used here can't really know which things are cardinality 1 and which things are cardinality many, it just wraps everything in a vector. And this is one of the areas where JSON-LD does differ, I think, at least in intention, a little bit from RDF. In that they do have like if you know, it is still plain JSON in the sense that you get back, and so you see, you know, like, is this an array that I'm getting back, or is this just a single value? And you can, you know, you can process it as such. Now I am actually curious. So in case of public key, yeah, it just says ID and then the URL, so that value is probably not what we want. So there's a little bug there, but I don't know if we need to fix it on stream right now. I might fix that by next time. Also, and maybe that's enough for the first stream. I think, like, okay, so we've gotten, actually, let's go one step further. So, okay, here's our cleaned up JSON-LD namespace. Let's take this out again. So we now can expand the context. We can cache the context. We can apply the context to get a fully expanded thing. Now I basically want to take that and turn it into something that looks like idiomatic Clojure data. And for that, we're going to introduce these prefixes. I'm actually going to call them common prefixes. Basically, now we're going to take these fully expanded URIs, I should say, and turn them into namespace keywords that are a bit more familiar to us. And so that logic is here. See, instead of 2CLJ, let's call this yeah, compact works. Also, let's not do that. I don't like having these fully qualified names in my code. I like to have aliases. Yeah, and let's actually give it an expanded value. Expanded JSON-LD. like another function that combines the two. Okay, let's first actually, before I walk over this code a little bit, let's look at what this does. Compact using the common prefixes. All right. So this, I think this is cool. I find this quite exciting. So Clojure's namespace keywords are awesome. And they're a thing that I miss in a lot of contexts, that like in the idea that you don't just use ambiguous short identifiers, but that you use something, you know, a bit more qualified. It just makes your code so much more clear, so much more understandable. And so I miss this because often when you're talking to, you know, to external systems, to databases, to APIs, they don't know what a Clojure, you know, what a namespace keyword is. And so, you know, there's not really a good way to talk namespace over the wire. You know, if you're dealing with external systems, you often have to make a choice of like, okay, which simple identifiers are we going to map these to and from, or are we just going to use the simple identifiers that we get? But this is actually a really great solution to this, right? Like because there's also a thing even, you know, just within Clojure code where it's like, okay, you know, like if you really want to be unambiguous, maybe you need to use, you know, fully reversed reversed domain name syntax, but then they kind of get unwieldy, and then you need to start using these aliases and stuff. But what we're now basically able to say is, well, you know, we're not going to let our namespace keywords get out of hand. We just use these, you know, fairly short and understandable prefixes. But within our application, within our domain, we have a unique way of mapping these back and forth to full URIs, and they're actually, you know, globally defined RDF property names with well understood, well defined semantics. And so now we can, you know, we can talk with other systems that understand these RDF identifiers. So I find this super exciting. So I'm gonna wrap it there for today. Next steps are gonna be, okay, how are we gonna actually get this into a database? And so I've experimented a little bit with that as well. Gonna use Postgres and some of the cool Postgres capabilities. I think that might be a good topic for the next stream. And then also, you know, now we're dealing with all of this internally, but at the end of the day, we're gonna have to turn this back into this compacted JSON-LD representation, because that's what other servers understand. And so we'll see how to do that probably next stream as well. Because of course, you know, so this is kind of where the whole thing breaks down. You know, JSON-LD clearly was designed, you know, maybe stopgap is a little bit not very flattering, but in my mind it is kind of a stopgap. It's sort of saying like, okay, well, you know, people expect these, you know, just plain maps with plain property names, so we're gonna make APIs that deal with that, and then we're just gonna slap on this context to make it unambiguous. My fear is, and I've asked around, I haven't really looked at, for instance, the Mastodon code, but I've asked around a little bit, and it seems to be that implementations slap on these contexts as a matter of ceremony, but don't actually interpret them. What that means is that, you know, in theory, say you know, there's a name or a profile name property or something, we should be able to call that something else in our responses, as long as in the context it maps to the same fully qualified URI. And I don't think that's going to fly. So we are going to have to make sure that we map back to the same kind of form that other implementations expect. It also seems that actually the specs for ActivityPub are mostly written in that way, that they kind of, you know, talk about these properties and also only sort of perfunctory kind of mention, you know, the context you should be using. But that's fine, you know, we actually using the context that the others use, we should be able to map back to the form that the others understand. So yeah, I'm going to wrap it there. Thank you all so much. Again, would love to, you know, like have your thoughts on all the stuff I'm doing here. This video will go live, so you can comment on the video. And yeah, like do post on the Fediverse using the ActivityPub in Clojure hashtag. And then maybe I can take some of that input and use it into the next stream. I think the next stream is going to be around the same time on Sunday, so in 2 days. So hopefully see some of you there. Thank you very much.